In this lesson, I want to begin our unit on projectile motion. So to do that, first thing I want to do is review what we have already talked about. If I have an object that is sitting at rest, so we're going to drop it from rest, then what is its accelerated motion? How is it going to go in free fall? So we're going to say that it has a y velocity, initial y velocity of 0 meters per second. So the question is, what is its velocity after 1 second? So if I give it a time of 1 second, what is the velocity at this point? Well, to do that, we're going to use this formula. And we know that if we take this formula, our initial velocity is already 0. We have established that. And so if I rewrite the formula, my velocity is going to be gravity times time. We've also said that gravity has a value, that my gravity has a value of 9.8 meters per second squared. As we study this, this is the rate of acceleration of an object as it falls. Because this is accelerated motion, and because it goes in this direction, we're going to say that gravity has a value on the way down of a negative 9.8 meters per second squared. So we're going to make this negative as it goes down. And it's just simply because it's graphical, and it makes it consistent with our graph. So in the negative y direction, gravity is negative. So what is its velocity after 1 second? So if we use this formula, so my velocity is equal to a negative 9.8 times 1, then my value is, let's make that bigger, my velocity after 1 second is a negative 9.8. So what is its velocity after 2 seconds? So let's bring this down here. So after 2 seconds, what is the velocity of this object? Same thing. What is my y after 2 seconds, my y velocity after 2 seconds? So I'm going to do the formula again, negative 9.8 times 2. So that's going to be a negative 19.6 meters per second. So every second that it falls, it accelerates. In other words, the velocity changes every second. So what I need for you to do is hit the pause button, and I want you to go ahead and tell me what is the velocity after 3 seconds. So go ahead, hit the pause button, and make sure you know that answer. Welcome back. So the next thing, if the velocity is accelerated, is the distance between the two objects accelerated as well? Well, the answer, of course, is yes. And so what we need to calculate is what is the distance between these 2 points. If it has dropped for 1 second, what is the distance? And we're going to use this formula. Our change in y, which is my y distance, is equal to initial velocity times time plus 1/2 gravity times time squared. Once again, we've already established that my initial velocity is 0, so we can take that out, and so my formula is going to be my change in y is equal to 1/2 gt squared. So after 1 second, how far has it fallen? So my change in y is equal to 1/2 negative 9.8 times 1 squared. Of course, we know that answer is 4.9 meters. So the distance it has fallen from this point to this point is 4.9 meters. So how far has it fallen after 2 seconds? And we are not calculating the distance between, let me get this line straight. We are not calculating the distance between here and here. We are calculating it from here to here. So we're coming all the way down. We're starting at 0. We're coming all the way down to this point. So what is my distance for that? So I'm going to move this stuff down so I can write that in there. So what is my distance at 2 seconds? So my distance at 2 seconds is my change in y is equal to 1/2 negative 9.8 2 squared. That's going to give me a total of negative 19.6 meters. It's negative because it's going down the y-axis, negative y-axis. So what I need for you to do right now is pause this and tell me how far it's gone after 3 seconds. What is the distance here? Well, this is all review. We've done this before. We know these formulas. This is not new information. But what I want to do now is, what does it look like when we use it in projectile motion? When we have projectile motion, there are two things that are happening at once. We have a horizontal and a vertical. These two things are taking place at the same time. That means that we have something going on the x-axis as well as something taking place on the y-axis at the exact same time. And so with this, our horizontal component is constant. The horizontal component is always constant. I'm going to show you what this means in just a minute. And the vertical component is accelerated. Why is the vertical component accelerated? The vertical component is accelerated because of gravity. Gravity is that acceleration rate that we have, and it is constantly changing as it falls. The horizontal is constant because gravity does not have an effect. The formula that we're going to use for our horizontal component is our standard velocity formula. Our x velocity is equal to our x distance divided by time. Notice there's no acceleration in this formula. The gravity formulas are there it is. Our formulas for the accelerated component are the ones that we've talked about before. We have final velocity is equal to initial velocity plus gravity times time. Our change in y is equal to our initial velocity times time plus 1/2 gt squared. And then final velocity squared is equal to initial velocity squared plus 2 times gravity times my change in y. We will use these three formulas when we are doing our accelerated motion in the vertical direction. One more thing before we move to a problem, very important. The horizontal and vertical components are independent to each other. What that means is that the horizontal component has no effect on the vertical component as an object is projected. The vice versa is true. The vertical component has no effect on the horizontal component as the object is projected. Very important that you understand this concept. They are independent to each other. So what does that look like in a problem? Well, let's do one. So let's say I have an object, and this object is traveling with a horizontal velocity of 8 meters per second. It comes off the table or the building, let's say, because I'm going to make this a pretty tall building. It comes off at 8 meters per second. What is going to be, let's do this first. Let's calculate the range that is going to hit the ground. So here's my dx. What is my range from the bottom to where it hits? How does that look? What is that going to do? Well, if I have an object coming off at 8 meters per second, I need to calculate the range. So what do I need? Well, we've already established what our formula is for the constant. My bx, which is what this is, my x velocity, horizontal velocity, is equal to my horizontal distance or displacement divided by time. So I have my horizontal velocity, I'm trying to find my horizontal distance, I need time. So how do I find the time? Well, let's say the building has a height of 15 meters. So this is going to be my y distance. My y distance is 15 meters, then what I'm going to look for is how long does it take for this object to drop straight down. And we've already done that. We looked at this right here. We know how long it takes for it to drop, and we can calculate if I have a distance, how long is it going to take for this object to drop. So if I take this, I can use this formula. That my change in y is equal to my initial velocity times time plus 1/2 gt squared. Take this formula and plug it in. What is my vertical initial velocity? So my vertical initial velocity, well, that's 0. That's going to be 0 as this thing comes off. When this flies off, it's all horizontal. There's no vertical component at this point. So we can take this off and we can say that 15 is equal to 1/2 negative 9.8 t squared. And this has to be negative because we're going down. That's in the negative y direction. So square root my t, or let's try that again. Once I square root and I get my time is 1.75 seconds. So it takes 1.75 seconds for this to drop. Now the reason we can do this is because of what we said right here. Oops, wrong slide. It's because of what we said right here. If I take this, my horizontal and vertical component, they're independent to each other. So now I can come back here and I can look at it and say, okay, well, these are independent, so I can just calculate the time. Once I have the time, I can plug this number in right here and I can calculate my range. Well, the object is going to follow a parabolic path. There it is. We're going to follow this parabolic path as it comes down, and it's going to hit, smooth that where it hits, it's going to hit there. So what is that distance? So now I'm going to take my numbers. My horizontal velocity is 8, and I'm trying to find my distance, but now I know my time that it takes for it to go there because we just calculated it. And so now my horizontal distance that it lands is 14 meters. This is the start of our projectile motion. We will start with this, with an object coming off. This is an object that is launched horizontally. We will do more problems with this in the next segment.